What is computer language? Before we explore the topic of Java programming, first it is very important that we understand what is computer language. Computer does not know any human language. So they don't know English, French, Chinese, or any language for that matter. It only understands zeros and ones. Computer language, that zero and one language, it's called binary. Computers store all characters as numbers on hard disk because computer don't know what is hello or how are you is. The computer converts that into these numbers, zeros and ones, and that's how it stores that into the hard disk. The process of converting that data into binary code is called encoding. Now, to better understand, let's visualize it. Now, where is that 0 and 1 comes from? Your computer runs on electricity. If you unplug the power or if your battery runs out of your laptop, your computer will shut down, right? So computer to transmits the data, to save that data, it actually uses 0 and 1, and that 0 and 1 concept came from the electricity. 0 means off, and 1 means on. So this I or 1 that you probably see on your switch. If you go to your switch right now, or if you have an older switch, probably newer switch don't have those 0 and 1 anymore. But if you find one in your house, you're gonna look at it closely and you're gonna see 1 on top or at the bottom, depends which country you are in. So the 1 means that turn on. 0 means to turn it off. Similarly, the computer sends or saves the data on the computer or transfer the data through these zeros and ones. Now, moving on, let's put it in an example of how it could translate a word into zeros and ones. There is a chart that's called a binary chord chart. Each letter that we have has a number or a binary number associated with it. So like A has 100000001, B has 1000010, and so on. So now let's say if you type it in hello on your keyboard. Now, how your operating system or your computer is going to translate that into its processor or memory that, hey, this hello means these digits, so process it. So the first thing it will do is will take the first character, which is H. And by looking at the chart, you will see the H translates to 1001000, meaning on, on, off, off. Same thing, E translate to 1000101. L, L, and O 1001111. So that's like a cheat sheet the computer has, and computer knows that when the letter H comes in or E comes in, I'm gonna have to translate into binary. And again, the binary is on and off. So when the computer puts all these numbers together, it actually sends these signals as on off, on off, on off, on off, and that's how it actually move the data from one computer to another or from your keyboard to the hard disk. I hope now you have a better understanding of computer language. You might be wondering why programming languages like Java, Python, Ruby, and so on are necessary if computer already has its native binary language. That's an excellent question. Now, allow me to clarify one thing. It is indeed possible to write programming code directly in binary language, but it would be very tedious and time consuming. The reason we use these programming languages is that they enable us to write code in a manner that is more accessible for humans to understand, debug, and of course troubleshoot in case there is an issue. So ultimately, regardless of the programming language that you use, the code you write is executed by the computer hardware in the form of binary instructions. In addition, binary language is commonly known as low-level language, while other programming languages are referred to as high-level languages. It is important to note that the term low or high level do not imply any kind of ranking. Binary language is considered low level because it directly interacts with the computer hardware, while the other programming languages operate on top of it. When a higher level language communicates with a computer, there is an intermediary component that translates it into machine or binary language. This essential bridge that you see, that middle piece between them, is known as a compiler software. So, I hope this clarifies the concept of a computer's native language and why we utilize other programming languages. Types of programming languages. In this lecture, we will provide an explanation of the various types of programming languages. Please don't forget to subscribe to my channel and click on that like button if you like my video. Also click on that notification bell. Thank you. There are various types of programming languages, each designed with different purposes and applications in mind. Here are some of the main categories. First one is procedural programming languages. In procedural programming languages, a program is divided into a series of procedures or functions that are executed in a sequential manner. These procedures contain a series of instructions that are performed step by step to solve a problem or complete a task. Examples include C, Pascal, and Fortran. The next one is object-oriented programming language, which is the primary focus of our course. The OOP, which is in short of object-oriented programming, organizes the code around objects. Now, what is an object? An object can be anything that you see around you. For example, a table, a chair, a phone, a glass, or even a cat, a game player, or even a button. It describes what a thing is and what it can do. Examples of these languages are like Java, C++, Python, C Sharp, Ruby, PHP, and so on. I will cover the object-oriented programming in more detail in the next video. The next one is functional programming. Functional languages see computation as performing calculations just like a math. They focus on making things unchangeable and avoiding actions that can cause unexpected consequences. Examples include Haskell, Lisp, and Erlang. Then there are scripting languages. These languages are designed for scripting and automation tasks. They are often understood and processed as they are read, and they can handle different types of data without strict rules. Examples include Bash, shell scripting, or C shell, JavaScript, Perl, Ruby, and so on. Then going to the next one, which is the markup language. These languages are used to define the structure, presentation, and behavior of documents. They are not traditional programming languages, but are essential for web development. And examples of markup languages include HTML, XML, and CSS. Then we have query language. These languages are designed specifically for querying and manipulating database. SQL, which stands for Structured Query Language, is the most well-known example of such language. And there are some other ones, for example, domain-specific language, concurrent programming language, and logic programming languages. Object-oriented programming. In this lecture, we will discuss object-oriented programming in more detail, and I will try my best to explain it in a very simple way. In object-oriented programming, we mainly deal with objects. An object can be anything like a person, place, or a thing. It has a specific structure and can do certain things. If you think about things that are not considered objects, we're talking about entities that don't have a clear shape or form and don't do anything specific. Examples of such non object entities are emotions like happiness or abstract ideas like freedom. These things are not classified as objects because they don't have a physical structure and don't show actions in the same way as concrete objects do. Let me explain you the object-oriented programming through an example. Going back to the basics of programming, which is the procedural or sequential programming. In this type of programming, you write a code in a sequence, right? For example, we want to write a code which will have a set of instructions, and for that, we will use an example of driving a car and pick up groceries. So the code will look something like this. Unlock the car, start the car, check your rear view and side view mirrors, fasten your seatbelt, then of course drive to the nearest grocery store, buy a loaf of bread and a dozen eggs, and of course come back to your car and unlock the car, start the car, check your rear view and side view mirrors, fasten your seatbelt, and then drive back home. Now, if you notice that actions 1, 2, and 3, 4 are similar to actions 7, 8, 9, and 10. Imagine if you have to stop off at another store as well, then you are repeating these steps again and again, which is, of course, not efficient. So, what we do is we define an object and its functions in something we call a class. So, it will be something like class of an object, and the object will be the car. So, for example, we define car as an object and its class that will have functions of unlock the car, start the car, check your rear view and side view mirrors, fasten your seatbelt. Now, if we write our code again, it will become a lot easier to manage. Look at that. Object is the car, then of course drive to the nearest grocery store, buy a loaf of bread and dozen eggs, then again define object which is the car and drive back home. You see, now our code suddenly became from 11 lines to 5 lines. See, that's why the object-oriented programming became so popular. So object-oriented programming is a way of writing computer programs that focuses on organizing and managing data by grouping it together with the code that operates on the data. Or in simple word, it treats everything in a program as objects that have their own unique characteristics and behaviors. It helped programmers to create modular and reusable code by breaking down the program into smaller, self-contained objects that interact with each other. Just like we created the car as an object which has its own smaller self-contained program. This approach allows for easier understanding, maintenance, and of course, expansion of your program. So I hope this example that I have given you is enough and clear enough to make you understand what is an object and why we use object-oriented programming when we write a program. So far, we have learned all the different type of programming languages. Now let's spend some time to understand which language is best suited for which application. I want to start off with C++. C++ is a powerful and versatile programming language that was developed as an extension of C programming language. It was created in the late 1970s with the intention of adding object-oriented programming features. All right, so let's take a few examples of C++ applications that are available today. The very first one is the operating systems. Yes, most of the operating systems that you use or build on your computers nowadays are built using C++, plus plus, and examples are like Windows, Mac OS, and Linux. Then there are many games that are built using C++, plus plus, such as Grand Auto Theft, The Witcher, World of Warcraft, Doom, League of Legends. Moving on to graphics and multimedia applications, such as Adobe, Autodesk, Blender, and DirectX. Then there are financial systems that are built using C++. plus plus. Some of them are like trading systems, risk management software. Then there are database management systems that uses C++ plus plus language. And those database management system examples are like MySQL, PostgreSQL, and MongoDB. And then the embedded systems are also built using C++, plus plus, and those systems are automotive systems, medical devices, and smart home automation. All right, that's about C++. plus plus. Now let's talk about our main focus of the course, Java. Java is programming language that can run on the different computer systems without needing changes. Examples of Java applications are big business software such as customer relation management system, human resources management system, supply chain, and so on. Also, Java is heavily used on websites such as banking system, e-commerce platform, content management system. Mobile apps are also built using Java, primarily in Android. Mobile apps examples are WhatsApp, Facebook, Instagram, Spotify, Airbnb, Uber, and the list keep goes on. Then other applications such as scientific applications are used or are built using Java. And examples are image analysis, processing, computational chemistry, bioinformatics, astronomy, and so on. Then, not to forget the games. There are many games that are built using Java, such as Minecraft, Runescape, and many other puzzle and game or card games that are used using Java language. All right. The next one is Python, which is easy to learn and understand. Example of Python applications are web development. Now you probably notice web development is something that can be done using many different languages. It depends the purpose of your website. You could use different languages to build it. The examples of Python web applications are Instagram, Pinterest, Dropbox, and Reddit. Data analysis and visualization is another form of application that is built using Python, and examples are Jupyter Notebook, Pandas Data Frame, Seaboard. Then moving on, machine learning and artificial intelligence applications are built using Python, and some of them are image classification, virtual assistant, healthcare applications. Moving on to the list of applications using Python is scientific computing. Then we have automation and scripting application. We also have desktop GUI application that can be built using Python, and examples of those GUI applications are like calculator, text editor, music player, spreadsheets, and so on. All right, then not to forget games. Game development can be done using Python as well. And the example of games are Snake Game, Tic-Tac-Toe, Hangman, Sudoku, and many other applications. Then moving on to C Sharp. While C Sharp is a programming language made by Microsoft, it is used to create different type of applications such as Windows desktop application, like text editor, media player, file compression. Then there are web applications such as e-commerce website, real estate listing platforms, booking and reservation system, online learning management system. Other applications are like mobile application, which are fitness tracking, expense tracking, news feed, task manager. Then games. 2D platformer, racing games, adventure simulation games can be built using C Sharp. Then moving on to Ruby. All right, Ruby is a dynamic object-oriented programming language known for its simplicity and readability. Examples of Ruby applications are web applications mainly used for social networking websites, online marketplaces, and blogging platform. Then we use command line tools, or we build command line tools using Ruby. And those tools are like backup utility, password generator, network monitoring tools. Then there are automation scripts that are built using Ruby, mainly used within the operating system for tasks such as scheduler, database maintenance, deployment. Then other applications are like testing and quality insurance. And the last one, and not to forget, the most famous one that is coming nowadays, really famous, are the chatbots. Those chatbots used for customer support, travel assistance, job search, and language learning. So now I'm sure you understand why we have so many different programming languages and which one is best suited for your needs. In this lecture, our focus will be on understanding the distinction between a computer programmer and a software developer. We will explore the unique roles and responsibilities associated with each profession. A computer programmer is defined as a person who has expertise in programming languages and uses such languages to create code for applications. Additionally, they might help write tests for these applications. A software development, on the other hand, is more involved in the application design. They spend a lot of effort ensuring the usability and behavior of the application, including how users interact with it, the application flow, and its accessibility. Software developers frequently collaborate with clients to fully grasp their needs and choose the best possible solution to include into the application. The primary focus of a software developer is to prioritize understanding the customer needs and finding effective solution to address those needs. They place a strong emphasis on creating user-friendly application that effectively solve customers' problem. Let's consider a scenario where ABC Bank is well-established financial institution, recognizes the increasing demand for mobile banking services among its customer base. To meet this demand and provide customers with convenient and secure access to their account, ABC Bank decides to develop a mobile banking application. The project begins with a team of software developers in this scenario. They work closely with ABC Bank's product managers, business analysts, and user experience designers. They conduct a user research, gather insights, and analyze customer needs and expectations for that mobile banking application. Based on the information, the software developers create wireframes and design mockups of the application user interface. They focus on designing an intuitive and visually appealing interface, ensuring easy navigation and smooth user interaction. They incorporate user-friendly features such as Touch ID or facial recognition for quick and secure authentication, as well as options for personalized notification and account alerts. Throughout the development process, software developers maintain a constant feedback loop with stakeholders and customers, conducting usability, testing sessions, and gathering feedback to iterate and improve the application's design and functionality. They prioritize understanding customer needs, designing a user friendly interface, and ensuring an optimal user experience. While the computer programmers in this scenario collaborate with the bank's IT department, software architects, and software developers. They are proficient in programming languages. Their primary responsibility is to implement the technical requirements and architecture defined by the team. The programmers start by creating an authentication module, enabling users to securely log into their accounts. They implement encryption protocols and establish secure connections with the bank servers to safeguard sensitive information. They then focus on developing the core functionalities of the mobile banking application, such as displaying account balances, transaction histories, and e-statements, as well as integrating secure payment gateways for fund transfers. They ensure that the application adheres to industry standards and best practices to mitigate security risk. The computer programmers also work closely with quality assurance team to write comprehensive test cases and conduct rigorous testing, including functional and security testings. They prioritize the technical implementation of the application's features, ensuring reliability and accuracy. In this lecture, we will start with our primary focus of Java. Previously, we covered high-level and low-level programming languages and the purpose of each language and its applications. So now, let's start with the definition. As per Wikipedia, Java is a high-level, class-based, object-oriented programming language that is designed to have as few implementation dependencies as possible. It is a general-purpose programming language intended to let programmers write once, run anywhere, meaning that the compiled Java code can run on all platforms that support Java without the need to recompile. Now, that was the exact definition out of Wikipedia. So now let's put it in a very simple words. Java is a programming language that allows you to create software and applications for various devices like computers, smartphones, and a lot more. Whenever you go find the purpose of Java, one advantage of Java will be repeated and highlighted in all of its purposes that our Java is a platform independent language. Because of this advantage, Java is also called a two-stage system. This means that Java source code is converted to machine code in two steps. In the first step, the code is translated into a special format called bytecode by a program compiler. And in the second step, the bytecode translated into machine code by a program called interpreter. This special process makes Java more secure because the code runs in a controlled environment, preventing any harmful actions. So, thanks to this Java feature, which made Java more secure and gave it the ability to run on different devices without any changes. Java was also designed to be easy to learn and use and to be efficient and reliable. These characteristics have contributed to the popularity of Java and have made it a widely used language for building a variety of applications. Now, let's talk a little about the history of Java, which is quite interesting. So, Java was originally developed by James Gosselin, Mike Sheridan, and Patrick Norton at Sun Microsystems in the early 1990s. The project was initially referred to as Oak, after an oak tree that stood outside James Gosselin's office. However, the name Oak faced some legal challenges when Sun Microsystems realized that another company already had the rights to that name. Now, as a result, they had to look for an alternative name. Eventually, in 1995, the name Java was chosen as a replacement for Oak. Now, the name Java is said to be inspired by the coffee beans from the Java island in Indonesia, reflecting the team's passion for coffee. That's why if you see the logo of Java, it's a coffee cup because it is connected to coffee beans from Java Island, Indonesia. In the logo, the rising steam adds a fun and lively element, representing the language energetic and dynamic nature. So, Java was seen as a unique and catchy name that could be trademarked without an issues. So, using Java, James Gosselin, Mike Sheridan, and Patrick Naughton initially wanted to make a system for interactive television, but later they changed it to work on the World Wide Web. So Java was designed for one purpose but ended up being used for something else and became so popular on the internet. Java became available to the public in 1995 and became very popular because of its special features called Write Once and Run Anywhere. Then in 2010, Oracle Corporation bought Sun Microsystem, and that's when they got the Java programming language. Nowadays, Java is super famous and liked by many programmers all over the world. All right, I hope you learned something useful in this lecture as well. In this lecture, we will discuss the importance of Java. Java is an important programming language that has a significant impact on the software development industry. Java has gained widespread adoption and is considered one of the most popular programming language in the industry. It has a large community of developers and extensive usage across various domains. Therefore, Java is also known for its flexibility, which allows developers to adapt and extend the language to suit various programming needs. Some of the key aspects highlighting Java's flexibilities are libraries and framework, compatibility with existing system, development tools and ecosystem, community support, platform independence and backward compatibility, robustness and security. Let's go over them one by one and discuss them in more detail. The first one is libraries and framework. Java benefit from an extensive collection of libraries and framework that enhances its flexibility. These libraries cover a broad range of functionalities such as database connectivity, networking, web development, machine learning, and a lot more. Then the next one is compatibility with existing systems. Java's compatibility with legacy systems is another factor contributing to its flexibility. Java supports various integration mechanisms such as the Java database connectivity, remote method invocation, and Java message service, allowing seamless interaction with existing databases, systems, and services. Development tools and ecosystem is another important feature of Java. Java offers a robust ecosystem of development tools, including powerful integrated development environment like Eclipse, IntelliJ IDEA, and NetBeans. These tools provide features such as code completion, refactoring, debugging, and profiling, empowering developers to work efficiently and adapt their code as needed. The next one is the community support. Java benefits from a large and active community of developers who contribute to its flexibility. The community actively develops and maintains open source projects, libraries, and frameworks that extend Java's capabilities. This community support ensures a constant flow of new ideas, innovations, and solutions, enabling developers to adapt Java to their specific programming needs. Moving on, one of the most important features of Java is platform independence. So Java's platform independence is a fundamental feature that distinguishes it from many other programming languages. It allows Java programs to run on any platform that supports Java, regardless of the underlying operating system or hardware architecture. This means that a Java application developed on one platform can be easily executed on another platform without requiring any modification to the code. The key to achieving platform independence in Java is the Java Virtual Machine, in short, JVM. The JVM is an integral part of Java runtime environment, responsible for interpreting and executing Java bytecode. This eliminates the need for developers to rewrite or recompile their code for different operating systems, of course, saving time and effort. Then Java has another valuable feature called the backward compatibility. This means that newer versions of Java are made to work seamlessly with older versions. Applications built using older versions of Java can still run smoothly without needing significant changes when upgrading to newer versions of Java. Then moving on to the next one, which is robust and security. Java was designed with a strong emphasis on reliability, robustness, and security. Its strict compile time checks, exception handling mechanism, and memory management, which contributes to creating stable and bug-free applications. Additionally, Java security features such as sandboxing, strict access control, and cryptography libraries help protect against potential vulnerabilities and threats. All right, in conclusion, all these Java features makes it a versatile and reliable programming language for a wide range of applications in the ever evolving software development landscape. In this lecture, we are going to talk about how to succeed as a Java developer. One of the primary reasons to consider learning Java is its extensive adoption by top companies. With a history spanning over 20 years, Java has established itself as stable and reliable programming language favored by prominent IT corporations. Now, according to StackShare, around 10,000 companies include Java in their tech stack, including industry leaders such as Google, Netflix, Facebook, Airbnb, Uber, and many more. While these companies also utilize other emerging technologies, but Java remains a key component in their software development ecosystem. It is no surprise that highly trained and skilled Java developers are in high demand with attractive salaries, of course. According to Indeed.com, the average base pay for entry level Java developers is around $70,000 per year, with potential for significant growth as experience and skills increase. Now, salaries can reach up to $150,000 to $200,000 per year for experienced Java developers. According to Stack Overflow, that conducted a survey in 2022, Java consistently ranks among the most popular programming languages. All right, so now let's get back onto the topic how to succeed as a Java developer. It is important to stay up to date with the latest advancement frameworks and best practices through continuous learning. Explore online resources. There are many online resources where you could get your training, documentation, tutorials, and participate in forums to expand your knowledge. Apply your knowledge by working on real world projects. Then engage with the Java community. Join developers forum and participate in open source project. There are many that you will find online. So collaborating with other developers exposes you to diverse perspectives, fosters learnings, and helps you stay connected with the latest trends and opportunities. Okay, then familiarize yourself with powerful Java development tools like Eclipse, NetBeans, and IntelliJ IDEA. Now, these IDE offers a wide range of features that streamline development, debugging, and code maintenance, ultimately boosting your productivity. Then, not to forget, write clean, efficient, and well structured code. Follow coding conventions, use proper naming conventions, and leverage design patterns to ensure your code is maintainable and scalable. All right. Then another advice is invest time in understanding the core concept of Java, including object oriented programming, inheritance, polymorphism, and exception handling. A strong foundation will empower you to tackle complex projects with confidence. Then actively seek feedbacks from peers, mentors, and experienced developers to enhance your skills. Embrace constructive criticism, learn from your mistakes, and strive for continuous improvement in your coding practices. All right, by following these guidelines and continually refining your skills, you can position yourself for success as a Java developer, opening up a world of opportunities for you in a language known for its versatility, industry support, and robustness. In this lecture, we will talk about the Java software tools such as JDK, JRE, JVM, and IDE. To write and run a Java program, we first set up Java environment. Now, what is an environment? In general sense, an environment refers to the surrounding or conditions in which something exists or operates. In the context of setting up a Java environment, it specifically refers to the configuration and preparation necessary for running Java programs either on your local machine or on a server. Setting up a Java environment involves installing the necessary software and tools that are required to develop and execute Java programs. So, the first thing that we install is JDK, which stands for Java Development Kit. It contains all the tools required to run Java programs. JDK includes a Java compiler, which is used to translate Java code into a form that can run on a computer, as well as a set of libraries and tools that are needed to develop Java applications. Now, JDK includes a component called JRE, which stands for Java Runtime Environment. JRE includes libraries as well as Java Virtual Machine, in short, JVM, which is the most important Java component. JRE is a software package that provides a runtime environment in which applications can be executed. So JVM, which is a part of JRE, is a program that interprets Java bytecode and executes it on a computer, as well as a set of libraries and tools that are needed to run Java applications. Then we must have a code editor. We will use an IDE IntelliJ in our course, which stands for Integrated Development Environment. You can use other code editors such as Eclipse or Visual Studio Code, but we'll stick around with IDE throughout this course. An IDE typically consists of a source code editor, build automation tools, and a debugger. Some IDEs also include a compiler or interpreter. So, to put it in simple words, JDK, JRE, and JVM are stored one inside the other, level by level. Now we discuss the how Java code is actually run. Our Java code executes in two steps. The first step is compilation and the second step is execution. Let's talk about the first step. The code we write in Java is called source code. The source code is stored in a file with the extension .java. All of this source code is sent to the compiler, which is included in the JDK, and the compiler converts it into bytecode with the extension .class. This bytecode can be run on any other system that has JRE installed. If you write Java code in Linux, Windows, or Mac, we simply convert it to bytecode, which can then run on any systems. Therefore, Java is called a portable or multi-platform language. The first step, compilation, is covered now. Now come to the second step, which is the execution. In this step, the JVM takes this bytecode and converts it into native code. So the native code is the code that a machine can understand. Now tell me, what is the name of that native code that we talked about earlier? What is it called? It's called binary. Yes, if you guessed it right, excellent job. Once your bytecode has been converted into that binary or native code, your machine will be able to understand it regardless of which operating system it is running on. So, in summary, we write Java code and save it in the .java extension, and it's gonna be known as source code. Then JDK has a compiler that converts this source code into bytecode with the .class extension. This process is known as compilation. Then this bytecode is given to the JVM that is inside the GRE. This bytecode is converted into the native code by the JVM. This is called execution. So, I am sure by now you have a better understanding of each Java components and how they work together. I will see you in the next lecture.